Well, here's a classic. Compound interest problem. Okay, first a little bit of a background about compounding interest. Whereas with the interest problems we have done, we haven't mentioned anything about compounding. It's just been assumed that the rate of interest that your bank account has been getting is just applied at the end of each year. So if you start your account at $1,000 at a rate of 10%, then okay, at the end of the first year, whatever 10% of what you have, which would be $100, would be just added on to your balance. So you'd have $1,100. And then at the end of 2 years, well, you would take 10% of $1,100, which is $110, and add that on to the $1,100, and so on and so forth. So you're just, at the end of the year, you're taking 10% of what you currently have and adding it on, okay? Compounded interest problems divvy up the rate multiple times over the course of the year. So if we go at that same 10% rate, if we said we wanted to compound the interest twice over the course of the year, then once, halfway through or 6 months into the year, we would take 5% of what we have and add that on to our balance. Then whatever 6 months later, you would take your current balance and you would add on 5% of that. Okay, if you're talking about compounding interest quarterly, then 4 times over the year you would compound at a rate of 2.5%. So you divvy up the rate according to the number of times you're compounding. It's kind of a tough thing to understand. You could compound monthly by divvying up the rate by 12, compound daily by divvying up the rate by 365. You could compound every minute or every second. The more times you compound, the more times that interest rate is compounded, the more money you would have at the end of that year. Okay? Anyway, let's talk about letter A. So you open a different bank account, also using $2,000. This is just going back to the previous problem, which had the same rate. This bank account, the interest rate also is 1.2%. Okay? If the account is compounded quarterly, that just means it's compounded 4 times over the year. So it's not just 1.2% at the end of the year. It's compounded essentially 4 times at a 0.03% rate. I'm sorry, actually 0.3% rate, right? Write an equation that represents the amount of money in your account as a function of the number of years the account's been open. Okay, so look, these get a little bit tricky. I give you a formula for this, and I'll give you this on a test also, okay? So the amount of money you have, A, equals your principal amount, that's just your starting amount, $2,000, times 1 plus, so usually it's 1 plus 0.012. 1.012 was the multiplier in the previous problem. We just added the 0.012 from the rate. But now we're divvying up that rate n times, okay? It's the amount of times you're compounded, that's what the n means. So you're divvying up the rate of 1.2%, which is 0.012. You're divvying that rate up 4 times, okay? And then we're raising this to the power, well, the number of times we're doing it, because we are doing that 4 times over the course of the year. We're compounding 4 times, okay? So to the 4t, t just being the number of years. Usually the problems just deal with at the end of 1 year how much you have. Okay, so you plug in 1 for t. But just in general, if you wanted 3 years later, well, then you plug in a 3 for t, etc. So this is the equation that represents the same situation, but compounding the amount of $2,000, the original starting value, 4 times. Not just, 1 time at the end of the year, but 4 times. That would be the equation.